Hello, graded learners! Welcome to our Quarter 2, Week 4 of our lesson. Today's topic, domain and range of a function. When we say domain, it is a set of x values or the abscissa of the ordered pairs of a function. And range is the set of y values or the ordinate of the ordered pairs of a function. During the previous discussion, the different representations were discussed, such as set of ordered pairs, mapping diagram, table of values, rule or equation, and graph. Let us first discuss on how to find the domain and range of a function given the set of ordered pairs. Determine the domain and range of this given set of ordered pairs for 2, 5, 1, 6, 0, 7, -1, and 8, -2. To identify the domain, you have to look for the x-coordinate or the abscissa, and that is the set of 4, 5, 6, 7, and 8. And for the range, we have to look for the y-coordinate or the ordinate, and that is the set of 2, 1, 0, -1, and -2. For the second set of ordered pairs, we have -2, -1, 2, 1, 0, 1, 5, -1, and 3, -2. For the domain, you have to look for the x-coordinate or the abscissa, and that is the set of -2, 0, 2, 3, and 5. You can also write the domain as how it appears in the set of ordered pairs. We have the set of -2, 2, 0, 5, and 3. And for the range, you have to look for the y values or the ordinate, and that is the set of -2, -1, and 1, or you may write it this way, the set of -1, 1, and -2. Take note. List down the repeating number once. Let us now find the domain and range of a function given the mapping diagram. The domain and range are easily recognized in the mapping diagram. The domain is the first set of numbers in the diagram, while the range is the second set of numbers. Determine the domain and range of this given mapping diagram. The first set of numbers is -2, -1, 1, and 2. And what is its domain? Yes, that is the set of -2, -1, 1, and 2. And for the range, we have the second set of numbers, which is 5 and 3. And that is our range. How about the domain and range of this given mapping diagram? Yes, you're right. The first set of numbers is 3, 5, and 2, and that will be the domain of this given function. And for the range, we have the second set of this mapping diagram, which is -1, -2, and -3, and that will be the range of this mapping diagram. Domain and range of a function described by the graph. To find the domain and range of a function described by the graph, look in the x direction, from left to right, or horizontally, that is the domain. And for the range, we have to look for the y direction or the vertical position, upward and downward. Then, look for the beginning and its ending. Let us identify the domain and range of this given graph. As you can see, the arrowheads indicate that the graph extends in both directions. It extends to the left and right without bounds. So, the domain is the set of x such that x element of real numbers, or simply the set of all real numbers. Similarly, it extends upward and downward without bound. So the range is the set of y such that y element of real numbers, or simply the set of all real numbers. Let us analyze the second graph to identify the domain and the range. The arrowheads indicate that the graph is extended to the left and the right without bound. So the domain is the set of x such that x element of real numbers, or simply the set of all real numbers, while the range is the set of y such that y is greater than or equal to 1, because the arrowheads extended upward starting with positive 1. Take a look at the next graph. It is a horizontal line. This horizontal line passes through 0, -4. As you can see in the graph, the arrowheads extends to the left and right without bounds. So the domain is the set of x such that x element of real numbers, or the set of all real numbers. But the range is the set of y such that y is equal to -4, since the line passes through 0, -4. Here is the fourth graph. To determine the domain, consider the x values or inputs taken by the graph. The arrowheads extends to the right starting from 0. Therefore, the domain is the set of x such that x is greater than or equal to 0. For the range, look at the y values or the outputs taken by the graph. The arrowheads extends downward starting from -2. Therefore, the range is the set of y such that y is less than or equal to -2. Domain and range of a function given the equation. Take note that when dealing with the equation, we write y as the function of x or f of x. Determine the domain and range of the given equation. F of x equals x plus 5. In the given equation, notice that we can use any values for the function both in the domain and in the range. There is no limitations. So, for the domain, we have the set of x such that x element of real numbers, or the set of all real numbers. And for the range, we have the set of y such that y element of real numbers, or the set of all real numbers. Equation number 2. F of x equals the square root of x plus 3. What is its domain and range? Remember, we cannot take the square root of a negative number. It is called imaginary. So whatever be under the square root, it must be greater than or equal to 0. So we have x plus 3 is greater than or equal to 0. Taking its additive inverse, we have x is greater than or equal to -3. Therefore, the domain is the set of x such that x is greater than or equal to -3. And how about the range? Range is all real numbers greater than or equal to 0. And that is the set of y such that y is greater than or equal to 0. Determine the domain and range of this given equation. F of x equals 2 over x. As you can see, the given is a fraction, and 0 cannot be substituted as the value of x to the function because it will become undefined, since x is the denominator. So, the domain is all real numbers except 0, and it is written as the set of x such that x is not equal to 0. Since 0 cannot be the input, then it is not also possible to be its output. So, the range is the set of all real numbers except 0, and it is written as the set of y such that y is not equal to 0. Equation number 4. F of x equals 3x over x minus 1. This is similar to equation number 3. The denominator is x minus 1. All numbers can be substituted as the value of x except 1 because the denominator will become 0. And in that case, if you have 0 denominator, it will become undefined. So, the domain is the set of x such that x is not equal to 1. How about the range? To find the range, get the inverse of the function. To find the range of f of x equals 3x over x minus 1, we have to get the inverse of this function by following the different procedure. First, we have to replace f of x by y, and that will be y equals 3x over x minus 1. Next, interchange the values of x and y. We have x equals 3y over y minus 1. Next step is to multiply the equation by the LCM y minus 1, and that will become x times the quantity y minus 1 equals 3y. By distributive property, we have x times y is xy, and x times 1 is x. So we have xy minus x equals 3y. Then, combine similar terms, or by addition property, we have xy minus 3y is equal to x. Factoring out y. As you can see, in the expression xy minus 3y, the common factor is y. So we have y times the quantity x minus 3 equals x. By multiplication property, we have now y times the quantity x minus 3 times 1 over x minus 3 is equal to x times 1 over x minus 3. Then simplify. We have now y is equal to x over x minus 3. Using the inverse of the function, we have now y equals x over x minus 3. The denominator is x minus 3, so we can replace the value of x by any numbers except 3 because the denominator will become 0. Therefore, the range now will be the set of y such that y is not equal to 3.